vSphere HA. In this module, I'll discuss the vSphere HA features and also demonstrate HA by simulating a failed ESXi host in our infrastructure. HA host failure. vSphere HA provides protection for applications that are running on our virtual machines, as well as to provide protection for our virtual machines should the host that they are running on fail. HA would automatically restart our virtual machines on other hosts with available capacity should their original host fail. HA is tightly integrated with DRS. So should a host with its VM fail, it would restart those virtual machine on other hosts, whilst at the same time it would try to use DRS to balance the workload on those surviving hosts. HA also works to protect our virtual machine during a vMotion operation. So if our source host fails during migration, the virtual machine are automatically restarted. It is enabled at the cluster level, vSphere HA. So once enabled, one host is elected within the cluster as the master host. So this master host will communicate with our vCenter server and monitor our cluster VM state. This master host also would use a network and our data store heartbeat to determine a host failure or a failure in network that would cause a network isolation. HA is intelligent enough to determine when a host is isolated from the network or when it has crashed. An isolation is when a host cannot see network traffic coming from another host, really. So HA guess OS failure. The capabilities of HA can also be used in cases where the guess OS fail within one of our virtual machine. So once VM monitoring is turned on, the HA agent would communicate with the VMware tools, which is installed in our individual VM. And if the VM stops sending heartbeat or the VM process crashes, HA would reset that particular virtual machine. Next, we have HA and application failure. As with the guess OS failure, application monitoring on a VM also required the VMware tools installed in a virtual machine. With HA application monitoring, the HA agent on the host can monitor the heartbeat running in that particular VM. And when that application fails, that VM is restarted on that ESXi host. Okay, so for this to work, we would need a third-party application monitoring agent that is built to work with the VM application monitoring feature. Okay, here we have the HA heartbeat network. So there are a number of ways where HA would use heartbeats. Firstly, heartbeats are sent between the master and slave hosts. Secondly, heartbeats are used to determine whether a master or a slave host has failed. Thirdly, heartbeats are also sent over a heartbeat network. So the heartbeat network is implemented on the VM kernel port that is marked for management traffic. Okay. So as we can see, there are a number of ways where HA uses the heartbeats. And for this reason, we may want to deploy redundant heartbeat networking for HA cluster. So if we do not provide redundancy or redundant management network connections, we could set ourselves up to have a single point of failure in our infrastructure. So here we have a couple different ways where we could provide redundancy for our Heartbeat network. Firstly, we could deploy additional physical adapters and theme them for VM kernel management traffic. VMware recommendation for this is we deploy one adapter as active and one in standby with no failback adapter. Our second method we have is to provide, our second method to provide redundancy we have is the HA Heartbeat network is to deploy additional VM kernel ports on separate vSwitches. So this would be for our management traffic. So basically we would have two NICs connected to separate physical switches or a switch stack at the physical end to provide redundancy for our management network there. Also, we should take care with our HA implementation. So if you're planning or if you're undergoing a planned maintenance on one of our hosts, to avoid a host isolation situation or to have unwanted failover of our VM to another host in the HA cluster, we should take care to disable the host monitoring function during this period of maintenance. Once we get to the demonstration, I'll go into how we could enable or disable this. Okay, so let's go over to our vSphere web client and configure our HA feature. Okay, so as I mentioned, this is configured at the cluster level. It is enabled there. So let's go across to our cluster, host and cluster view. The two hosts that we'll be working on is ESXi1 and ESXi4. These are the only two hosts I have up and running now. So what we'll do is enable HA and have a look at some of the settings for that. Then I'll go ahead and power off this DSL VM, which is currently running on ESXi4. So I'll simulate a failure of our ESXi4 host, and then we'll see the HA feature kicked in there. Okay, so to get started with this, we'll first need to enable this feature. As I mentioned, it's done at the cluster level. So if I go to our cluster there, and then come down to HA, okay, I'm under manage, then settings for a cluster. Okay, so you could also just right click the cluster and go to settings too. They'll take you right there too. So I'll go to HA, and then by default the HA feature is turned off. Okay, so let me go ahead and hit an edit here over on the right. I'll hit an edit there, and then we have the option of turning on HA here. So I'll go ahead and turn that on. Recall the host monitoring feature I mentioned when we were going through our slides. This is where we would enable or disable that. So if we are going through a period of maintenance for a particular host, we may want to just turn off the monitoring, the host monitoring capability, so it would not unnecessarily try to move VM around in our cluster. All right. Moving on from that, we have our protection against storage connectivity loss. We could enable or disable that there. We have a couple settings at the bottom here too. Firstly, we have our virtual machine monitoring capability. By default, this is disabled. We could monitor the VM only. We did discuss this, and then we could also monitor the VM and the application. Okay, so we'll just leave that to off. Here we have our failure conditions and VM response. Let me just scroll on here. So we have our VM restart priority. Um, we could change the restart priority for a VM. We could disable that. We have low, medium, and high settings. And by default, it's set to medium there. Next, we have our response for host isolation. What we wanted to do, we could either shut down and restart the VM, or just power off and then restart the VMs. Okay. Following that, we have our permanent device loss settings and our all path down settings. But the main one I wanted to go through here is the admission control setting. Okay. So the admission control setting is how much capacity we would like to reserve within our cluster. So we could reserve one host worth of capacity. Okay. We could manually specify these here. We could also come down and set a percentage of capacity that we want to reserve. Or we could just select a dedicated host. We could say, okay, in our cluster, we want a dedicated host for HA, and we set that to one of our hosts in that cluster. All right. We could also not reserve any capacity at the bottom. And moving on from that, we have our data store for heartbeating settings. This is where we configure our heartbeat data store. Recall I mentioned we could use the network and the data store for our heartbeat services. So this is where we would select that particular data store. Okay, so let me just go ahead and hit OK here. I have this turned on. So I'll go ahead and hit on OK. Okay, should go ahead and reconfigure that. Okay, so HA is currently turned on. As I mentioned, our DSL VM that we'll be working on is currently on ESXi 4. Alright, so what I'm going to do now is pull up my VMware workstation, which is running these hosts here on the left, and I'll simulate the failure of ESXi 4, which is running a DSL VM. Okay, so let me just bring that up. So let's assume something goes like really bad here. Uh, let's say a motherboard fail on this ESXi 4. Okay, so here we go. We just power that ESXi 4 off. Right, let's just give this a couple seconds and we should see this change now. It would automatically go and restart this ESXi sorry, or DSL VM on ESXi 1. Okay, so this is currently running on 4. Let me see the status of this. It's still running here. Let's just give it a couple sec more. So bear in mind, this would not affect the virtual machine files because it is on shared storage. Okay, the VM files for this DSL virtual machine. Okay, let me move this here and let's just refresh here. Let's just refresh our view. Okay, so here we have it. Our virtual machine, it just restarted and it's currently now running on ESXi 1. Okay, this is still up and running. It was running on 4. We break ESXi 4, and this is now running on ESXi 1. Also, once we enable HA on our cluster, we would have this icon next to our virtual machine here. This would indicate that the VM is protected by VMware HA feature.